Now we'll see logarithmic test. Okay, when to use logarithmic test? We'll write it, okay. If summation un is a series of positive terms, okay, it is not actually given in the syllabus, but see that whenever the test fails and you are having the answer of x in terms of e, you need some test. That test is logarithmic test. Okay, that's the reason I'm telling you one problem based on this logarithmic. Okay, if summation un is a series of positive terms such that limit n tends to infinity, log un by un plus 1 is equal to L, okay, then summation un converges for L greater than 1, diverges for L less than 1, test fails for L is equal to 1. Okay, whenever the ratio test fails for x is equal to in terms of e, then we need to make use of logarithmic test. Okay, when ratio test fails for x equal to something in terms of e, then use logarithmic test. Okay, problem 1. Test for convergence of 1 plus x by 2 plus 2 factorial by 3 square into x square, 3 factorial by 4 cube into x cube, plus and so on. Okay, given series is 1 plus x by 2 plus 2 factorial by 3 square into x square plus 3 factorial by 4 cube x cube, plus and so on. Right? Neglect first term. Then I can write this as summation n is equal to 1 to infinity un, where un is equal to x power n. See that here I can write it as 1 factorial. So I write it as n factorial plus 1 factorial, 2 factorial, 3 factorial and so on. So nth term will have n factorial into x power n by, and see that here 2. First term is 2. Next term is 3 square or 2 as 2 power 1. Right? So I can write n plus 1 power n. Now I'll show you whether it is right or not. If I put n is equal to 1, 1 factorial x power 1 by 2 power 1 s. If I put n is equal to 2, 2 factorial x power 2 by 3 power 2 s. So it's matching. Right? This is greater than 0 for x greater than 0. So this gives a positive series. Now I can make use of positive series test. Now limit n tends to infinity, un by un plus 1 is equal to limit n tends to infinity, okay, n factorial x power n by n plus 1 whole power n by n plus 1 factorial into x power n plus 1 by n plus 2 whole power n plus 1. Okay, limit n tends to infinity un by un plus 1 is this, right? So rearranging the terms and cancelling, what we'll get, we'll see here. This is equal to limit n tends to infinity, okay, n factorial x power n by n plus 1 whole power n into, reverse it. So we'll get n plus 2 whole power n plus 1 by n plus 1 factorial. I can write it as n plus 1 into n factorial. So n plus 1 into n factorial into x power n into x power 1. Right? So I can cancel this term, this term, this term, this term. Right? Then this is equal to limit n tends to infinity. Clubbing the similar terms, I can write it as n plus 1 whole power n, n plus 1. So when clubbed, we can have the power as n plus 1 whole power n plus 1. So I'll club these two, n plus 2 by n plus 1 whole power n plus 1 into 1 by x. Then taking out n common from these two and cancelling, we'll get that as limit n tends to infinity, un by un plus 1 is equal to, okay, n and cancel, we'll get that as 1 plus 2 by n whole power 1 plus 2 by n by 1 plus 1 by n whole power n plus 1 into 1 by x, and here limit n tends to infinity. Okay, so this I can write it as limit n tends to infinity. Okay, better I'll separate the terms. Then I can write it as 1 plus 2 by n whole power n by 1 plus 1 by n whole power n, 1 plus 2 by n whole power 1, 1 plus 1 by n whole power 1 into 1 by x. Because I need to bring that into any of the formulae what we have written right today. So here 1 plus 2 by n whole power n and 1 plus 1 by n whole power n as limit n tends to infinity gives the exponential formula. Right? We have written that 1 plus x by n whole power n as limit n tends to infinity as e power x. Okay? And here this will give the answer as 1 plus 0. This will give the answer as 1 plus 0. But for these two, I'll get the answer in terms of e. Right? So I can write this as e square by e into 1 plus 0 by 1 plus 0 into 1 by x. Since limit n tends to infinity, 1 plus x by n whole power n is equal to e power x. Right? So now see that we are getting the answer in terms of e. I told you that when we get the answer in terms of e and the test fails, then we need to use logarithmic test. Okay? So this is equal to, I'm getting the answer as e by x after cancellation of these two. So limit n tends to infinity, un by un plus 1. I'm getting the answer as e by x, which is equal to L. When L is greater than 1, converges. When L is less than 1, series diverges. And when L is equal to 1, test fails. Right? So I can write, it implies summation un converges for e by x greater than 1. Or if I send this here, x less than e I can write. Okay? X, e is greater than x, or I can write in a reverse way as x is less than e. Diverges for x greater than e, and test fails for x is equal to e. Now see that test is failing at x equal to e, and I told you that when it is in terms of e, we need to make use of logarithmic test. Since test failed at x is equal to e, use logarithmic test. Okay, so put x is equal to e in un is equal to n plus 2 by n plus 1 whole power n plus 1 into 1 by x. So which becomes un is equal to n plus 2 by n plus 1 whole power n plus 1 into 1 by e. Un by un plus 1. This is un by un plus 1, right? So this I can write it as, okay, I can write this as n plus 1 by n plus 1 whole power n plus 1 into 1 by e. So un by un plus 1 is equal to, I can write it as, okay, here 1 plus 1 by n plus 1 whole power n plus 1 into 1 by e. Right? Now applying the logarithmic test. Now limit n tends to infinity, log of un by un plus 1 is equal to limit n tends to infinity, log of 1 plus 1 by n plus 1 into 1 by e. Then applying log mn formula to that, okay, or applying log m by n. Log m by n is equal to log m minus log n. So I'll use that formula here. So I can write it as limit n tends to infinity, log 1 plus 1 by n plus 1, okay, whole power n plus 1 minus log e base e. So this is equal to log limit n tends to infinity, okay, then this n plus 1 comes in front, so n plus 1 log to the base e 1 plus 1 by n plus 1, okay, minus 1. Then this is equal to limit n tends to infinity n plus 1 into, okay, we know that log of 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus and so on. So we can write this as, okay, 1 by n plus 1 minus 1 by n plus 1 whole square by 2 plus 1 by n plus 1 whole cube by 3 minus and so on Okay, then minus 1. Then this is equal to, sending this n plus 1 inside, we'll get limit n tends to infinity 1 minus 1 by 2 into 1 by n plus 1 plus 1 by 3 into 1 by n plus 1 whole square plus and so on minus 1. Then this plus 1 and this minus 1 will get cancelled. This plus 1 and this minus 1 will get cancelled, right? So here limit n tends to infinity. What we are getting the answer? Limit n tends to infinity. Okay, we are getting the answer 1 by n plus 1. Okay, limit n tends to infinity. I am getting the answer is equal to 0. 0 which is less than 1. So therefore, series summation un diverges for x is equal to e. Right? I am getting 0 here. Why? Because this one and this one got cancelled. Now as n tends to infinity, this term will give you 0, this term will give you 0 and so on. We'll get the answers as zeros. Right? So at x equal to e, it diverges. So therefore, summation un converges for x less than e and diverges for x greater than or equal to e. Okay. So with this, positive series tests are completed. Okay. The next, we can start alternating series, Leibniz test, and absolutely and conditionally convergent, and finding interval, okay, for the series, interval of convergence. Yes, in this we forgot to write that n into log un by un plus 1, sorry. Okay, here I missed n into, okay, missed here n, sorry, just I'll add this n here, n into log un by un plus 1. So I should put here n, okay, I forgot that to put here. So here I'll have the term like n here and n here, okay. So because of which I'll have the answer as here, okay, small change is there, sorry. Limit n tends to infinity, I'll have the answer as here minus half, okay, like this I'll have n, okay. So sending this n inside, then I'll have the answer as n by n plus 1 plus 1 by 3 into n by n plus 1 whole square plus and so on like this. Okay. So when I cancel these terms, then I'm going to have the answer as minus half. Okay. Minus half is less than 0. So therefore it diverges. Okay. A small change is there. So it becomes minus half when it is less than 0. Minus half when we are using x is equal to e in this. Okay. So just I forgot to put n here, because of which we were getting that 0 as the answer there. Okay. So n should be there in logarithmic test. Even when we wrote the formula, I think we missed there n. So just add n to that. Okay. N should be there.